Welcome to my channel. In this video, I will be explaining about hot working of metals. So what is hot working of metals? If we heat a metal above recrystallization temperature and below melting point of that metal and apply repeated force or continuous pressure and deform it to a required shape, it is called hot working. Because we heated the metal to a elevated temperature and then after apply force. For this reason, this is called hot working of metals. This process can be done only on metals, not for non-metals. Different types of hot working are hot rolling or called as rolling, hot forging or called as forging, hot extrusion or called as extrusion. So in this figure, this is rolling. In hot rolling, a heated metal is passed between two rollers to deform it to a desired shape. Generally, in rolling, the thickness of the material is decreased. Metal is passed through a pair of rolls while heated to a temperature above its recrystallization temperature and below melting point. The rolls reduce the thickness and change the cross-sectional area of the metal. Rolling has different applications in industry. So in hot rolling, we heat a metal above recrystallization temperature and below melting point. So take a metal as X. The recrystallization temperature of this X metal, suppose 750 degree Celsius, and the melting point of this X metal, suppose 1200 degree Celsius. So what will be the temperature for hot working of this metal X? The temperature must be between these two, the 750 degree Celsius and 1200 degree Celsius. The temperature can be 800 degree Celsius. The temperature can be 1000 degree Celsius and whatsoever, but it must be between these two temperatures. If the metal is soft, then the temperature is lower. If the metal is hard, the temperature must be higher. So the example of hot working is hot rolling, and more examples are hot forging. In hot forging, metal is heated and shaped using localized compressive forces typically applied by a hammer or a die. In industry, forging has many applications. Hot forging is used to manufacture components like gears, crankshafts, connecting rods and other high strength pairs. Another example of hot working is hot extrusion. So this is a figure of hot extrusion. In hot extrusion, metal is forced through a die orifice at an elevated temperature, creating a specific cross-sectional shape. In industry, hot extrusion has many applications. Hot extrusion is employed for producing tubes, rods and complex cross-sectional shapes. So this is hot working of metals. Now we will discuss about the advantages of hot working. Hot working has many advantages. Firstly, we heated the metal at an elevated temperature, then apply force, repeated force or continuous pressure or force as a blow. So the metal is already in soft condition, that is in plastic condition. So the force required is very low. The advantages are here: ductility and impact resistance are improved. If we do a hot working on a metal, then the ductility and the impact resistance of that metal improved. Second, large deformations in the metal are easily obtained because no state hardening occurs. The metal is heated to elevated temperature, so the metal becomes soft, so we can deform a large material at one step. Next, porosity in metal is minimized. The porosity becomes less in material after hot working. This process is rapid and requires less power. We heated the metal, so metal become like plastic. The metal is in a semi-solid state, so the power required is less. Brittle materials can also be hot worked. Brittle material which is very hard, we can easily hot work. The final or last is very favorable grain size can be achieved. In hot working, we can achieve a very favorable grain size in the final product. Next, I will discuss about limitations of hot working. Though the hot working has many advantages, some limitations we have to face. Those are tooling and handling of hot metals are difficult and costly. We have to handle the heated metals, so the handling is very difficult because the metal is heated. We can touch the metal in bare hand, and the tooling cost also is very high for hot working. Close tolerance on dimensions not possible. When we heat a metal, it expands. After getting cool, the metal contacts. So the close tolerance on dimensions not possible. No dimensional stability. I told right now that if we heat a metal, the metal increases in length, and when the metal cools, it decreases in size. So the dimensional stability is not present here. Surface oxidation and decarburization occurs. When metal is heated, it creates chemical reaction with the oxygen of air, and the carbon of metals also creates chemical reaction with the air. Next is high energy consumption. We have to heat the metal, so the energy consumption is very high. So this is hot working. So in this video, I have discussed about hot working, examples of hot working, advantages of hot working, and limitation of hot working. Hope this video was useful for you. Thank you for watching this video. For more updates, subscribe this channel and hit the bell icon.